All right, so number 4 says that the distribution for home prices in a certain part of the city is skewed to the right. So they're telling us that it's skewed right. And they're telling us that it looks something like this. Again, skew, it just means that it's stretched out in that direction. We haven't talked about this part of it yet, the mean equal median, mean greater than median. We want to understand why that is. So more than just memorizing this at the bottom, it's more important that we kind of understand maybe why that would be the case. So let's before this is talking about home prices. Just a quick example though. Let's say that we were talking about your test score. We'll talk about some test scores, and then we'll kind of come back and talk about home prices. So just kind of put this over here on pause for a second. So I don't know. Let's say you had some test scores. Let's say you got a 50 on a test. You got a 62 on a test. You got a 73 on a test. You got an 84, and let's say you got a 92. Right. So if I asked you what's the median of this, what's the middle? Oh, well, we could see that the middle would be 73. And what we're wanting to do here is that I'm wanting to see if I throw in an outlier. It may not necessarily be an outlier, but if I throw in kind of an extreme measure on either end, how does that change things? What would the average of this be? So, for instance, if we talk about the average for this particular data set, we know how to find the average. Just add them all up and divide by what's there, right? So let's say 50 plus 62 plus 73 plus 84 plus 92. And then divide that by 5. We get 72.2. So we see that this is roughly symmetric, right? That the median and the mean are pretty close to one another. So if I drew a little distribution curve, I would get kind of this bell-shaped curve where what happens is that the median and the mean are pretty close to each other, right? We could say that the median and the mean are pretty equal to each other. Now, what if we changed, and so I want to then kind of throw another scenario into it, is that what if you, instead of on this lowest test, let's say that your teacher found out that you were cheating. Not that you would do that, but just a little hypothetical here. So instead of a 50, let's say your teacher found out you were cheating on that test and they gave you a 0. So, and we'll keep all the other numbers the same. So they just found out you were cheating on that one test. So here's the rest of your test. Now what do you think a 0 is going to do to your average? Right? Your average, which is your mean, is going to bring it down. So if I look at the median, what's the median here? Well, the median is still 73. So you notice that that had no effect or impact on the median. Now how's that going to affect your average? Well, we'd expect that a 0 is really going to probably drop our average. I don't know, let's change that into in the calculator. So we'll say 0 plus 62 plus 73 plus 84 plus 92, and then divide that by 5. So you see that our average dropped to a 62.2. So what happens is that if the mean and median are equal, right, we have this nice symmetric curve. But what happens, and where we get this idea of something either being skewed right or skewed left, is the average. If I draw my curve on this one, so let's say that I had my median, right? My median in this case was 73, which that was the same for both. But what happened was that test that you were cheating on, it brought your average down to a 62 as compared to a 72. So your average kind of slid down here a little bit. So let's just say, we're just kind of estimating, but let's say that's your mean. So what we would say is that because you got a 0 on that test, it brought your average down. It didn't change the middle, right? If we line them all up, the middle is still the same. So the median doesn't change, but the mean got pulled pulled down. And the reason why this curve gets stretched out this way is because we have to account for the fact that our lowest grade was a 50, but now our lowest grade, so let's say that's 50, now our lowest grade is a 0. So I have to stretch that curve all the way out to my lowest number, which in this case would be 0. So that mean slides to the left. So we would say that in this case that it's skewed left. And so what we say is that the median is a resistant measure, right? So the median is resistant and the mean is non-resistant. And what we mean by that, the median's resistant, meaning that you could change numbers here on the left or right, and it doesn't impact or affect what the middle number is. And so that's why in a lot of cases, if you see statistics reported in terms of home prices, salaries, listen to the word they use. They'll use the word the median home price within Ventura County rose 5% or whatever it might be. So the median isn't affected or impacted by outliers, right? So that we say the median is resistant, meaning it puts up a fight. He's not easily influenced. Whereas the mean, we would say, is non-resistant. So we would say that the mean is non-resistant. So what happens, meaning that the mean gets easily influenced, right? So that's just kind of some notes. Let's kind of come back and hopefully now we can answer the question. So if we have something that says it's skewed right, so if we have, they're saying home prices, so let's say these are home prices, and we're saying that those home prices are skewed to the right. So what it means is that if it's skewed to the right, that means it's stretched out to the right, right? So skewed, maybe you just kind of think of that word skewed, you know, that it's stretched out in one direction or the other, right? Whereas something that's symmetrical, it's balanced. It's not stretched left or right. So here, home prices we're saying are skewed to the right. So what that means, our median's in the middle. If we're saying that it's skewed to the right, that means that that the average is being pulled to the right. Because let's say we have kind of a normal neighborhood with some normal houses, and then one person comes in, they build like this $10 million mansion. Well, that's going to pull the average price of the home price in the neighborhood to the right. It's going to raise it. So just like a low test grade lowered your class average, you know, one expensive house coming into the neighborhood is going to skew that to the right. So what would happen is that, let's say this would be our mean. Okay. So which measure would be more accurate? Well, what we would say here is that the median is more accurate because it is resistant to outliers. So we can count on that number a little bit more because we know that it's not easily influenced. Which measure, mean or median, would be greater? Well, we've already said that if it's skewed to the right, that means there's, you know, one kind of outlier out here that's pulling it to the right, so that the mean, it may not just be one, by the way, it could be more, but the idea that there's a few maybe data points that are pulling this to the right. So the mean is greater. And actually sketch a sample. So what I just wrote right there, I should have copied that down here. But so the mean is greater, and our evidence of that would be this right here. So what we just drew, right? That really should be down here. So that would be our evidence that the mean is greater because we're doing that sketch. All right, so go ahead and pause now and try number 4 on the right side.